and the CEO of Synopsys. Please.
Thank you. It's an honor being here and to have the right forum to talk about AI governance. I want to approach it from a commercial and private company standpoint. But before I start, it's important to understand the complete stack of AI. AI starts with semiconductor chips that is powering this amazing disruptive technology and the software that runs on it, all the way up to market-specific applications that the users will experience with AI. Now, given the disruption of AI that's going to touch pretty much every market, will be more intelligent and more connected, it's important to think globally as far as an ecosystem and how do we act responsibly in order to make sure safe and secure AI. Given I'm approaching this from a semiconductor point of view, if you look back at the last 60 years, it took 60 years for the semiconductor industry to reach $500 billion in sales. And it will only take 7 years to double in size to reach $1 trillion. And that 7 years to reach $1 trillion, almost all of it will be driven by AI capacity that is needed for the infrastructure to train these models, as well as the inferencing of these models on every application that we will be using. Despite many significant disruptions over the last 3-4 decades, like the invention of personal compute, mobile devices, the internet, we have not witnessed the inflection point that we will be seeing as significant as it is with AI. Historically, the semiconductor market optimizes based on performance of the chip, power consumption of the chip. With AI, we'll have to add other elements of optimization, including security and safety of those chips. Now, who is Synopsys? We provide software for design engineers that are developing these sophisticated semiconductor chips. As you know, semiconductor chips are the most complex engineering tasks that humankind ever witnessed. And it's important to automate as much as possible and reduce that complexity through the software that our industry provides to the engineers developing these chips. AI provided a significant opportunity to accelerate and improve the process of developing these chips. And it was very much welcomed in our industry, given the shortage of skilled talent to work in that domain. So we were able to achieve both the speed as well as optimize along the vectors of power, performance, etc. There are many common principles around AI, and they were described earlier in a number of the talks. I want to focus at the semiconductor level, at the chip level. What are the practical things that companies are doing today in order to implement a safe and secure semiconductor chip as you go all the way up the stack when you are applying AI from an applications point of view? I'll give a couple examples. One of them is the governance compliance, to make sure that every chip is aware of where are the components that got integrated into that chip. Think of it as a bill of material of the chip. To ensure security and privacy, where you can insert what's called IP, intellectual property, focused on the security of the chip to make sure that is not vulnerable to unauthorized access. The other aspect is environmental efficiency and governance. As you know, the build-out of the semiconductor chips is so significant that is consuming a significant power in order to support these massive data centers. So what are the things that we can optimize at the semiconductor level in order to make it practical to continue that race forward in building that infrastructure? Now, as a public company, we have a number of efforts in order to deploy AI inside our workflows. We have about 20,000 engineers inside our company. So how do we use AI for our own efficiency and acceleration? We have created an AI Center of Excellence with the objective to educate our workforce around the AI ethics, risks, practices, transparency with our customers. How are we training our models as we're providing them the technology to use to develop these chips? And a continuous monitoring of the performance of the AI applications that we have in our product and the product that we're bringing for our own use. The second is the commercialization of AI. We actually started our AI investment around 2017. So we've been about 7 years selling AI, and our customers are using AI, our products, to improve the efficiency and further optimize their chip and semiconductor design. We expanded our AI effort to include generative AI. In other words, how do we bring in new skills into the semiconductor industry, leveraging generative AI as a knowledge base to improve the efficiency of the engineers? And as I said earlier, given the shortage of the engineer, this is a great example of AI in use to improve and accelerate the performance of the industry. And I don't want us to forget the power aspect. And here you see a couple numbers. One, by the use of AI on chip design, we're able to reduce the power consumption of the chip by 30%, while improving the productivity of designing these very complex systems by 15x. Now, as we race forward in the development and the use of AI, and again, I'm speaking from the semiconductor industry perspective, we cannot forget about the ecosystem and the governance of that technology, which is a very important element to ensure that the use of it is ethical, is safe, and secure. With that, I would like to thank you for listening to the silicon perspective as we look at the optimization all the way from the core foundation of silicon to the application level of AI. Thank you.
Thank you very much, Mr. Ghazi. Thank you for sharing. Thank you. 女士们、先生们，当前在人工智能不断创造商业机遇、深刻改变投资格局的同时，同步产生了哪些治理问题和治理机遇呢？那么接下来。